We have here the information given to us in item 12.9 of Levine. So in this particular item, you have here 542 milligrams or 0.542 grams of a non-electrolyte compound which is unknown, which we'll now call as Z, being dissolved in a certain mass of the solvent A. If we now try to compare the freezing point depression of Z to the freezing point depression when 679 milligrams of urea, CO, parenthesis NH2, 2, being dissolved in the same mass of the solvent A, we find that the freezing point depression of Z is 1.65 times the depression observed for the urea. We are now supposed to compute for the molar mass of Z. Now for this particular item, not much is known about our solvent A, so instead we'll have to make do with whatever items that we have and then plug it into our equation for the freezing point depression. So we can now write the following. Delta T for the unknown compound Z should be equal to negative Kf times the molality of Z. Now plugging in what we know about our compound Z, which is really only its mass, you now have the following. Kf is unknown times the mass of Z divided by its also unknown molar mass divided by the mass of the solvent A. Simplifying this expression over here, we arrive at this expression. Again, no values of Kf or Ma are known, so we'll have to make do with this one. And so we make a similar expression for our urea to find delta Tc. Now for the delta Tc, it turns out that we know much more about urea than our compound Z. Namely, we can simply compute the molar mass of urea, which we find is 60.056. So once again, using the freezing point depression formula, we're able to write this expression right over here. And simplifying this, we'll get the delta Tc equal to this expression. Now, utilizing the mathematical expression given to us in the statement of our problem in 12.9, namely that delta Tz is equal to 1.65 of this one, we're now able to arrive at this particular expression right here. In both sides of the equal sign, we can see that Kf can be cancelled out. This is because in both the unknown compound Z and our urea, the same solvent is used. Also, M sub A can also be cancelled out since in both cases, the same mass of solvent was used. Now using our calculators, we should be able to compute now the molar mass of our unknown compound Z, and it turns out that its molar mass is 29.05 gram per mole.